So I wanted to finish the problem I started in class where you're drawing a 5-card hand from a standard 52-card deck. And so I want to finish with parts C and D. And so in part C, we're trying to calculate the probability of getting 4 of a kind. So 4 of a kind, for example, would mean maybe you got 4 queens. So that would be all of the queens. And then some other card, maybe a 3 or maybe an ace of some suit. Okay, or it could be a different value. Maybe you got 4 2s and then you got a 10 of hearts or something like that. Okay, so we already know that the number of outcomes in the sample space is 52, choose 5. So we just need to figure out how many outcomes there are that have 4 of a kind. And so the probability of 4 of a kind is going to be the number of ways we can draw 5 cards, which is 52, choose 5. And on the top, we need the number of 5-card hands that have 4 of a kind. So you can probably go directly to counting to do this, but let me show you a little bit of kind of a reasoning that sometimes helps me to solve this problem. So sometimes I just try to start a tree. I don't draw the whole tree for something that has this many outcomes. So if we want to generate all the hands that have 4 of a kind, so we're going to think through the first step, and that's our 4 of a kind that we get. So for the 4 of a kind, you could get 4 aces. Remember, these do have suits like ace of hearts, ace of diamonds, ace of spades, ace of clubs, but I'm not going to write those down. Or you could get 4 2s and so on. And I'm not going to write them all down, but they're going to go down to 10s, jacks, queens, and kings, where you have 4 of those cards. Okay. For the second step, then you're going to need a 5th card because it's a 5-card hand. So if you have 4 aces, your 5th card is going to be something that's not an ace. So actually there are 52 minus 4 or 48 cards left that are non-aces. So you could have any of the 2s, the 2 of diamonds, the 2 of clubs, or sorry, spades, and so on. But there are going to be 48 cards here that are non-aces, because 52 total cards minus 4 aces. And that's actually going to happen for every single one of these. You're going to have 48 additional branches because there are, if you have 4 2s, they're going to be 52 minus 4 or 48 non-2s, and you need to pick one of those for your 5th card. Okay, so in this way you can see that there's going to be basically 13 initial branches. So these branches, there are 13 of those. Aces through jack is 11, queen's 12, king is 13 values. And then there's going to be 13 times 48 for the terminal branches. There's going to be 48 for every single one of the initial branches. Okay, so that's one way you could do this, as 13 times 48 over 52, choose 5. And if you want to go the straight, and I'll actually go ahead and calculate this, but if you want to go the straight combinatorics way and just use some combinations and permutations, another way you could think of this as, so alternately, without using a tree or anything at all, the probability of 4 of a kind, you can think of as you're going to pick one of the 13 kinds as your kind, like an ace, a 2, a 3. So that's going to be 13, choose 1. You're going to pick the kind. Oops. The kind or the value. There's 13 of those. You only need to choose 1. Once you've chosen the kind, you need to figure out how many there are to choose 4 of the cards of that kind. So for each kind, there's only 4 cards. So 4, choose 4. There's actually only one way to choose the 4 cards once you've chosen the kind that are going to be the 4 of a kind. Next, you have to choose a different card than the kind. So if your 4 of a kind was a queen, you've got to choose something else. And there's going to be 52 minus 4 or 48 that are different from your 4 of a kind, 48 cards. And you need to choose just one of those to complete your 5-card hand. So, and then the denominator is still 52, choose 5. So that's another way, and it ends up being exactly the same number as the tree, partial tree method. Let me go ahead and calculate this final fraction. So it's 13 times 48, I'm just using my calculator, is 624, and then 52, choose 5, is 2,598,960. So this is going to be a super low probability. If you write that out as a decimal, you'll get the same exact answer, the second method, just using counting. Okay, last, I want to do part D here, which is the probability of 2 pairs. So that means 2 pairs and then one card that is different from those 2 pairs. So the probability of, do a different color so you can see it, for part D is the probability of 2 pairs. Okay, still have a 5-card hand. So 2 pairs would be something like maybe 2 aces, an ace of hearts and an ace of spades, and maybe a 2 of clubs. Well, they don't have to be in a row, so let me make that clear. 3 of clubs and a 3 of diamonds. And then you have a 5-card hand, so you're going to need one more card that's different from those. So maybe that's a 5 of diamonds. Okay, so that's a different kind. Remember, the ace and the 3, the value is the kind. Okay, so let's just work through using counting how you figure out the probability of 2 pairs. You still have a 5-card hand, so the denominator is 52, choose 5 possible 2-card hands. So the first thing I'm going to do is I'm going to choose the 2 kinds that are going to be in my pairs. And so for that, the way I choose the 2 kinds is going to be 13, choose 2, or the combinations of 2 kinds chosen from 13. It's important that this be combinations, because if you choose as your kinds from the list ace, 2, 3, 4, all the way up to 10, jack, queen, king, you're basically picking 2 of these to be your 2 pairs, the kind for your 2 pairs. So if you pick jacks and queens, that's the same as you pick queens and jacks, because there's a pair of each. There's not any differentiation between those kinds. Okay, so once you chose your 2 kinds, say you picked 3s or something, maybe you pick 3s and queens, then you have to choose, there's going to be a certain number of ways. You can choose your 2 3s out of the 4, and then there's a certain number of ways you can choose your 2 queens out of the 4. So how we calculate that is going to be 4, choose 2 is the number of ways of choosing the first pair once the kind is determined, times 4, choose 2 is the number of ways of choosing the second pair, for example, from the 4 queens that you're going to have. Okay. So now that you've picked the 2 pairs, you have to figure out the number of ways that you can pick the odd card, the 5th one, that is just all by itself. It doesn't have the same value. So you need that to be different. It can't be aces or it can't be 3s. It can't match the first, the 2 pairs, the kind for the 2 pairs. So there are 8 cards that are eliminated from being your 5th card. So if you calculate 52 minus 8, that's going to be the number of cards you can pick that 5th card from. And you only want to pick 1 card from there. So it's 52 minus 8, choose 1. Okay, so then we can calculate this out. 13 choose 2 is going to be 78. 4 choose 2 is going to be 6 times 6. And then 52 minus 8 is 44, choose 1, so that's going to be 44 on the top. The bottom is still 2,598,960, and so on the top I'm going to get 78 times 36 times 44, and that is going to be 123,552 over 2,598,960. So if I actually get a decimal, that's about rounding to the thousands, 0.047 for that.